Hello my dear students, this is Reema. So in today's session we'll be discussing exercise 7.1 of chapter triangles, class 9 CBSE maths. So question number 1, in quadrilateral ACBD, AC is equal to AD. In quadrilateral ACBD, AC is equal to AD. AC is equal to AD and AB bisects angle A. So CAB will be equal to DAB. Okay, show that triangle ABC is congruent to triangle ABD. What can you say about BC and BD? Okay, so we have to prove these two triangles congruent. So that is ABC and ABD. AB is a common side, okay, of these two triangles, and also BAC is equal to BAD. Why? Because angle A is bisected by AB. So this angle and this angle will be equal. Also this side is equal, that is AC is equal to AD. So by SAS congruence rule, triangle ABC is congruent to triangle ABD. So this is proved. Now what can you say about BC and BD? BC and BD is equal by CPCT, that is congruent parts of congruent triangle. So we can write BC is equal to BD. In bracket we can write CPCT. Question number 2. ABCD is a quadrilateral in which AD is equal to BC. ABCD is a quadrilateral in which AD is equal to BC and DAB, that is DAB is equal to CBA, that is these two, that is CBA, that is these two angles are equal. Then prove that triangle ABD and triangle BAC, that is ABD and triangle BAC is congruent. Okay, here these two sides are equal, that is given, and also these two angles are equal, given, and also see in triangle ABD and triangle BAC, this is a common side. Okay, so side, angle, side. So by SAS congruence rule, these triangles are congruent. And what about the second one? We have to prove BD equal to AC. BD equal to AC. BD will be equal to AC by CPCT, congruent part of congruent triangles. And angle ABD equal to angle BAC. A, B, D and BAC. So this this angle and ABD and this, okay, this is also equal because by CPCT of these two triangles. Moving on to question number 3. AD and BC are equal perpendiculars to line segment AB, that is AD and BC are perpendiculars to AB. So this angle and this angle are 90 degree. Okay, show that equal perpendiculars. Equal perpendiculars means what? BC will be equal to AD. Okay, so this also equal, these sides are equal. And show that CD bisects AB. Show that CD is bisected by AB. So we have to prove OD equal to OC. Okay, and see this triangle OBC and OAD. Okay, these sides are equal and these angles are equal 90 degree, and also these two angles will be equal by vertically opposite angles. So by AAS congruence rule, these two triangles are congruent. Okay, and in this congruent triangles, look at OD and OC. OD will be equal to OCY, CPCT. So CD is bisected by AB. So moving on to question number 4. L and M are two parallel lines intersected by another pair of parallel lines P and Q. L and M are two parallel lines intersected by another pair of parallel lines P and Q. Show that triangle ABC is congruent to triangle CDE. So ABC and CDA are congruent. We have to prove this. So here this is our figure, and we know P is parallel to Q and AC is a transversal. That is, P is parallel to Q and AC is a transversal. Therefore, BAC, that is this angle BAC and DCA, these two angles will be equal. That is, angle BAC is equal to angle DCA, that is alternate angles. Okay, and now also L is parallel to M. Okay, see, L is parallel to M and AC is a transversal. So therefore angle BCA and angle DAC, these two angles will be equal. That is, angle BCA is equal to angle DAC. Why? Alternate angles, because L and M is parallel and AC is a transversal. So now in triangle, that is ABC and triangle CDA, we have what we have, B, that is BCA equal to DCA, and also BAC is equal to angle DCA, and also this is a common side. So what? ASA congruency rule. So therefore by ASA congruency rule, we have triangle ABC congruent to triangle CDA. Okay. So question number 5. Line L is the bisector of angle A and B is any point on L. That is, line L is a bisector of angle A. So QA, that is QAB is equal to angle PAB. This is a bisector. L is a bisector of angle A and B is any point on L, and BP and BQ are perpendiculars from B to the arms of angle. What are the arms of angle A? These two are the arms of angle A, right? So BQ is a perpendicular to this arm and BP is perpendicular to this arm. So angle BQA and BPA is 90 degrees. Show that triangle APB is congruent to triangle AQB. Here angle Q and angle P is 90 degree, and also L is a bisector of angle A. So QAB will be equal to PAB. So these two angles will be equal, and this is a common side. So by AAS congruency rule, these two triangles are congruent. Okay, and second one, we have to show BP is equal to BQ, or B is equidistant from the arm of A. BP is equal to BQ because why? CPCT. It's congruent part of congruent triangles. So therefore B is equal distance from the two arms of angle A. Moving on to question number 6. In figure 7.21, AC equal to AE. AC equal to AE. Okay, AC equal to AE and and AB equal to AD. AB equal to AD and B angle BAD equal to angle EAC. BAD equal to angle EAC. These two angles are equal. Show BC equal to DE. Okay, so now let's take these two triangle with the with one side BC and one side DE. That is, we'll take AB, C and ADE. Okay. So in triangle ABC and ADE, that is in triangle ABC and ADE. Okay. It's given here angle BAD and angle EAC. So that is angle BAD is equal to angle EAC. Okay, so we'll write that. So angle BAD is equal to EAC is given. See, this is the angle. Angle BAD and angle what EAC is equal. So now to that equation, let's add this angle, that is angle DAC, this small angle, no? Let's add that. So to this equation, let's say this is equation number 1, adding angle DAC to 1. Okay, DAC to 1 is angle BAD plus angle DAC is equal to angle EAC plus angle DAC. So what is angle BAD plus angle DAC? This is equal to angle BAC. Okay, it will be equal to angle EAC. EAC plus angle DAC will be equal to EAD. Here AB is equal to AD, that is given, and AC is equal to AE given. Also angle BAC is equal to angle EAD. So therefore by SAS congruence rule, triangle ABC is congruent to triangle ADE. So in this triangle, BC will be equal to DE. Why? CPCT. Okay. Moving on to question number 7. AB is a line segment and P is its midpoint. AB is a line segment, P is a midpoint. So these two will be equal. D and E are the same points on same sides of AB such that BAD, okay, this angle is equal to ABE, this angle. Okay, so these two sides are equal and these two angles are equal, and EPA is equal to DPB. Show that triangle DAP. So this triangle DAP and this triangle DAP and triangle EBP are congruent. Okay, so now here we know this angle is common in this triangle. Okay, we have these two common angle, and also this side is equal. Okay, and now also it's given EPA is equal to DPB. So now let's add EPD, okay, to this angle, that is EPA, then it will be DPA. And now let's add DPE to this angle DPB, then also we'll get EPB angle. So this angle will be equal to this angle. So by ASA congruence rule, these two triangles are congruent, and AD is equal to BP, that is AD is equal to BE CP CT. So moving on to question number 8. In a right triangle ABC, right angle at C, M is a midpoint of hypotenuse AB. M is a midpoint of hypotenuse, so therefore BM is equal to AM. Okay, so M is a midpoint of hypotenuse AB. C is joined to M. C is joined to M and produced to B such that DM is equal to CM. So these two are equal. And now show that triangle AMC is congruent to triangle BMD. So that is AMC and BMD are congruent. So here we know what CM equal to DM. CM and DM, that is given. Okay, and also we know that these two angles are equal, that is by vertically opposite angles. So angle AMC is equal to angle BMD, vertically opposite angles. Okay, and also it is CM and DM, and also AM is equal to BM. AM is equal to BM given. Okay, so therefore by SAS congruence rule, okay, side angle side, by SAS triangle AMC is congruent to triangle BMD. Next we have to prove angle DBC is a right angle, that is angle DBC is a right angle we have to prove. So now in this we have proved AMC is congruent to MBD triangle. Now we know that according to CPCT, MAC angle and MBD angle will be equal. So if these two angles are equal, see, these are alternate interior angles. So therefore BD is parallel to AC. Okay, so we'll write that. So in triangle AMC and triangle BMD, angle MAC is equal to angle MBD by CPCT. Also they are alternate interior angles. Therefore AC is parallel to DB. Okay, AC is parallel to DB. That is AC is parallel to DB. And then what? BC. Okay, BC is a transverse. These two are parallel. BC is a transverse. Therefore, these two angles will be co-interior angles. So, you know, in parallel lines and transversal, the sum of co-interior angles will be 180 degree. Sum of co-interior angles will be 180 degree. Therefore angle ACB plus angle DBC is 180 degree. You know, angle ACB is 90 plus angle DBC is 180 degree. Therefore, angle DBC is 90 degree. Now we have to prove triangle DBC is congruent to triangle ACB. That is, triangle DBC and ACB are congruent. Now we know DBC ACB. So this is a common side, and also we have proved A, that is AMC and MBD is congruent. So therefore these sides also will be equal. So we have this common side, and this sides are equal. Also this angle is 90 degrees. So by SAS congruence rule, we can prove DBC and ACB are congruent triangles. So next we have to prove CM is equal to half AB. So we have proved triangle DBC is congruent to triangle ACB. So therefore DC will be equal to AB. Why? CP, CT, that is congruent part of congruent triangles. So therefore we also know DM is equal to CM. DM is equal to CM, which is given. Okay, and now that is CM. CM is equal to half CM is equal to half CD. Now you know CD is equal to AB. Okay, so CM is equal to half AB. That is, CM is equal to half AB, and we have proved it.